Welcome back. Polynomials and rational expressions is our next topic, and we're going to carry that on over in here and talk first a foundational beginning intro into just reviewing what each term stands for and what everything means. Now here we have a variable and we have a number in front of the variable. That exact definition of that number is a coefficient. It's a number in front of the variable. The variable is, of course, the unknown. It's called an unknown because the amount that it can stand for, or the value, varies. Hence the word variable. All right. This is classified as a term. We have other terms down here. We have, I'll load these up in case you cannot see them. They are 2x y squared. We have 2x squared y. And then we have a good old single y. Now, the thing you have to be careful of is this. Both of these have the same letter. We have an exponent of 2, but the exponent applies to the x in this term and to the y in this term. So this is where things start getting a little exciting, if you will. How many terms are there in each of these? We have 2x to the third minus x squared minus 4x plus 2. We have how many terms in that? That would be a grand total of 1, 2, 3, 4 terms. This one here is 4x plus 6x squared. We have 2 terms there. And down here we have 3a squared minus 5a plus 4. 1, 2, 3 terms in this one. Okay, let's pay very close attention to these and pay attention to the exponents or the signs that are given. All right. Polynomials, 2 or more algebraic terms written as an expression. That's the definition. Now we have other terms that can sometimes cause people to have confusion, but they're really not that confusing. If you've heard the terms monomial, binomial, trinomial, okay, mono means one, or mon means one. That means there's one term. If you hear the word bi, you're talking about 2 terms. If you hear the word tri, you're talking about 3 terms in an expression, trinomial. After that, we don't get into quadnomial or anything like that. Everything after that is classified as a polynomial. More than one term. So anything past one term you can classify as a polynomial. All right, and we have various examples over here of polynomials. Now, writing your polynomials in standard form, there's a correct way and there's an incorrect way. All right, this would be a representation of the correct way. Notice the first term, x squared, is at the beginning. Okay, followed by a coefficient with this term as a coefficient and a variable, followed by just a number. Okay, the highest powers come before the lowest powers. This one in turn would be incorrect because the highest power is not at the front of the expression. All right, here we have another example, 2x to the third plus 4 s squared minus s plus 5. This is correct because the highest power is located at the front of the expression. On down here we see another one that is totally incorrect because the highest powered term is 3 places back in the front. All right? Adding polynomials. This scares a lot of people. Not necessarily that bad. All we're having to do is we're really looking for like terms, things that are alike. Okay? In this first example, we have 4x squared plus 6x plus 3, the quantity of these, plus the quantity of 2x squared plus 5x minus 1. Now, this looks overwhelming. Okay, there's different ways you can do this. Some people like to take this expression and align them with the other. Okay, very simple. Some people like to almost connect them with a rainbow to say, okay, I got a 4x squared plus a 2x squared. That's another alternative that is very good. Others like to circle the like terms. Okay, 4x squared plus 2x squared. Both of these are positive, so you would wind up with 6x squared. All right, you can put a different shape around the next ones that are alike. So then we have a positive 6x plus a positive 5x, which would be a positive 11x. And then the final 2 terms we have negative 1 plus a negative 3, and that would give us a positive 2. So we've combined the like terms. So there's various ways to do this. Whatever way helps you or works best for you is just fine. So we've combined that, very simple. On to the next slide. Now we're adding polynomials, which means we have more than, we have a lot of terms here. Okay? Here's an example. This is what I'm talking about right here. Notice these terms look very similar. They are not. Why? Because the exponent 2 is with the x in the first one. The exponent 2 is applied to the y in the second one. So these two are their own individuals. Okay? Alright, now we've got 7x squared y, and both of these, okay, look very similar. And there's nothing fancy, one's not heavier weighted or larger than the other. I'm going to put this one to the front because x is squared first. Okay? Has to do with the alphabet. X comes before y. So I'm going to put 7x squared y, and then I'm going to put, notice, negative and positive is going to stay in negative. 14xy squared. I'm going to put a little check over these, lest we know I'm done with these. Now we do have like terms right here. We have 3xy, and we have a negative 2xy. So that's going to be a very simple. We got a negative 2 and a 3, which gives us a positive, and that's going to be a plain old xy. Okay? So this is where you really have to pay attention to these polynomials, because an exponent in one place or another can really throw you off. So let's take a look at this one. We're looking for like terms. Okay, we've got 3x squared y here. That looks pretty large. I have xy, another instance, just like up here. I've got the 2 applied, the exponent to the y here, and the 2 exponent applied to the x here. I'm going to go ahead and put this one first. 3x squared y plus 2x y squared. Alright, which means these two are completed. Now I'm looking at x's and y's all over the place. Okay, so I have like terms here with x squared. I got a 7x squared minus a 5x squared. That's going to give me a positive 2x squared. Alright, so these two are completed. And then y squared, I've got a negative 3y squared plus a 3y squared. Those two cancel out. And I'm left with 3x squared y plus 2xy squared plus 2x squared. Very simple. Subtracting. Not unlike adding. Okay? Now you want to look to distribute, okay, into the second polynomial. This will change the sign of each term. So as we're distributing, as you look here, we've got negative x squared and we've got 5x squared. It's negative, okay, as if it's a negative 1, would leave us with a 4x squared. Okay? Same thing, we can circle the like terms if we need to. So that gives me a 4x squared. I've got a negative 4x. Now right here is also something you want to watch out for. I'll use a very different color. We got a negative and a negative. Negative and negative become a positive. So that's going to make this a positive 3x with a negative 4x. So that's going to still make this a negative, and it's just going to be x. All right, now I've got 4x squared minus x, and my last two terms are 5 and 2. Now again, I told you earlier to watch the negative, where the negative applies here, along with this positive, which means this is a negative 2. So I have 5 minus 2, and that's going to leave me with a positive 3. So now I have my expression all simplified out, 4x squared minus x plus 3. Moving on to the next one. Okay, now, I've got 3x cubed, 4x squared, minus x plus 2, minus the quantity of x squared plus 5x minus 2. Alright, so we have a bunch of information up here. We're looking for what? Like terms. Alright, I have nothing over here in this group, or in this expression, that's cubed. So I know 3x to the third is going to be my first one. Mark it out if you want to. Now, like terms. Here we go. 4x squared and negative x squared. So, combine those. Positive 4, negative 1 leaves me with a 3x squared. Okay? My next two terms, draw a little triangle around them. We have negative x and a negative 5x. This negative and positive become negative. So that's going to give me a subtract 6x. Now here we go. Negative and a negative for my final terms. Make that a positive. So I have a positive 2 combined with the other positive 2 is going to give me of variables in here. All right, I'm looking for what? I'm looking for the largest. And I'm going to choose, this one right here is my largest because it has 3 variables and the x is squared, okay? Now, I also have to pay attention, close attention, because I have a negative. All right, so this first term is going to be negative 4x squared yz. Now, because I am who I am, you do not have to do this, I'm going to mark this out. It lets me know I am done with that. Now, I really have to look and see. Now, I do know that these two, xyz, xyz, are like terms. However, I'm going to be using those a little later. Okay? I also have like terms right here. Using various shapes helps us to realize that these are like terms as well. Okay? This one is all by itself. Okay? It's x squared z. Now, we got the various choices. We got x squared here, we got x squared here. Okay, we got x squared here. I'm going to go ahead and use these two because it's xy. Z comes after y. I'm going to plug it in a little later. Okay? So I'm going to combine the 2x squared y along with this 7x squared y. But I have to watch. Negative and negative. Okay? Which makes that a positive. So I've got 2x squared y plus 7x squared y, which is going to give me positive 9x squared y. So I've completed these. Finished with these. I have this next one, this lone individual in this equation by itself. It's coming up next. Going in next because it has a squared variable. None of these variables are squared. So very simple. It's a negative. I'm going to just drop it on in. Negative 4x squared z. Put a little line in there so we know that that's a z. And that's a terminal line. Alright, so I've completed this. All that I have left now is to combine my last two like terms. Again, a negative and a positive here. So this is going to become a negative 2xyz. I also have a negative 8xyz like terms with the negative. So my answer is going to be negative 10xyz. And these terms have all been combined with a new simplified expression. One thing that you definitely want to check out is you can do all of this, a lot of this with these new manipulatives that we like to use, algebra tiles. You can check out this website. It's Algebra for All. It's a great website that allows you to use interactive algebra tiles in solving a lot of these expressions. It's very simple. You can start with simple and easy expressions and ramp up all the way to harder expressions where you're using the tiles to help solve and combine terms like this that we just did. So it gives you a visual demonstration, a visual display also of how to solve this. So check out that website, Algebra for All, and I don't think you'll be disappointed. Up next, Charlie Clark's going to share with us multiplying and dividing polynomials.
Thank you, Jamie, for showing us how to do combining like terms and simplifying polynomials by adding and subtracting. And now I'm going to talk about multiplying polynomials. If you have used some of our other videos, you would remember the law of exponents, which applies to multiplying polynomials. This is just an example to show you. Some people see that problem and kind of freak out because they don't know or remember how to multiply polynomials or the laws of exponents. So I'm going to break it all down for you. If you only have two terms and two terms, this is a binomial times a binomial, and we have to use the FOIL method to get the answer. And what FOIL stands for is first, outer, inner, last. First is this first one times that first one. Outer, this one is outside times that one is the outside. Inner is these two inner ones or these two here. And the last term is the 3 and the negative 2. And what that looks like is law of exponents. X times x is x squared. That's first. Outer. X times negative 2 is negative 2x. And then I stands for inner. The inner terms are positive 3x, which gives you positive 3x. And last means positive 3 times negative 2, which is negative 6. So now I have 4 terms. I'm going to circle my like terms and combine them together. I don't have any other x squared terms, so I'm going to put the x squared first so it'll be in standard form. I like to box mine up. Different people use different methods. I got a negative 2x and a positive 3x. If I combine those together, I get positive 1x. And then I got minus 6. So if you multiply x plus 3 times x minus 2, you will get x squared plus x minus 6. Multiplying polynomials have a different example. It says make sure I remember my exponents and my rules of exponents I had in another video. When you multiply polynomials together, you multiply the coefficients, and the coefficients are the numbers if you don't know what that means. So you multiply the numbers and you add the exponents. Okay? So my coefficients are the 2 and the 3. I multiply the 2 and the 3 and get 6, and then I add the exponents because they have the same base, leave the base the same, add the exponents and get 5. So 2x squared times 3x cubed is 6x to the 5th power. Now we got some more examples we're going to multiply out for you. Again, I have a binomial times a binomial. If I use the FOIL method, basically I teach people that a binomial times a binomial, 2 times 2 is 4. So when I get finished, if I don't have 4 terms, I did something wrong. So I'm going to multiply these out for you. First, x times x is x squared. Outer, that is x times y. That's going to be a positive xy. The inner terms are negative 3y and positive x. That's going to give you a negative 3xy. And your outer terms are negative 3y and positive 1y is going to give you negative 3y squared. I started with 2 times 2. I should have 4 terms when I get finished. 1, 2, 3, 4. I do that. And now I have to combine the like terms. I don't have any other x squares. I got an xy here and an xy here. This is a 1. So I got a positive 1 and a negative 3. Positive 1 and negative 3 is a negative 2 xy. I don't have any other y squared terms, so I'll bring the negative 3y squared down. So the answer to this one is x squared minus 2xy minus 3y squared. This one's going to be a little bit lengthy. I have 1, 2, 3 terms times 1, 2, 3 terms. Does anybody know what 3 times 3 is? Correct, that's 9. When I finish multiplying, I'm going to have 9 terms that I have to combine together. And how I do that is, I take the first term times each one of these. So 1 times 3 is 3. I take the second one times these 3, gives me 6. And the last one times each one of these 3 gives me 3 more, which is 9. This one's going to be nice and long, so bear with me. 3x squared times 2x squared. Remember your law of exponents. 3 times 2 is 6. X squared times x squared is x to the 4th. And I take the 3x times the positive 4x. 3 times 4 is 12. X squared times x is x to the 3rd. And I take the x squared times the negative 7. 3 times negative 7 is negative 21. I have no x term with that, so it'll be x squared. And now I'm going to take the negative 9x and multiply by each of these 3 like I did the first time. So I'm going to go negative 9x times 2x squared. Negative 9 times 2 is going to be negative 18. X and x to the 2nd is x to the 3rd. Negative 9x times 4x. Negative 9 times positive 4 is negative 36. I got an x and x gives me x squared. And then negative 9x times negative 7. Negative times negative is a positive. That's going to give me positive 63x. And bear with me, I'm going to multiply one more time. Now I'm going to take the 5 times the 2x squared. 5 times 2 is 10, so I have 10x squared. Then I have 5 times 4x. 5 times 4 is 20x. And last but not least, positive 5 times negative 7 is negative 35. Let's see if we got 9 terms, if that's what we're supposed to have. Trinomial, 3 terms, times a trinomial, 3 terms, 3 times 3, I should have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So far, so good. Remember that if you can't remember how many terms a certain polynomial has, the terms are separated by either a plus or minus sign. That kind of simplifies it for you. Now I got to combine them all together, and I have to put it in standard form, which means I want the highest variable first. The highest variable, if you look through all my variables, is x to the 4th. So I'm going to write it first. I'm done with that one. I got an x3 here. I got an x3 here. I don't see more x3s, so I'm going to take my positive 12 and my negative 18 and get me negative 6x to the 3rd. Okay, I got those done. Now I have an x squared here, an x squared here, and an x squared here. So I'm going to do negative 21 and negative 36 is going to be negative 57, negative 57, and positive 10 is negative 47. X squared. So now I've got all the x squared terms done. I have an x here and an x there. I got a positive 63 and a positive 20. That gives me positive 83x. And last but not least, I got minus 35. And don't get scared of these problems. They're not more difficult, they're just longer. It just takes a little bit longer. You got to pay attention to what you're doing and combine the like terms correctly. So our final answer is going to be 6x to the 4th minus 6x cubed minus 46x squared plus 83x minus 35. Not any more difficult, just a lot longer problem. So that took care of multiplication. Now we're going to do division. On some of these dividing polynomials, it's like canceling out fractions. But the bad news is on some of these, you might have to do some factoring before you cancel anything out. This one is pretty easy to see because both of these two terms I can take a 2 out of each one of them. But I'm going to jump over to some factoring and then I'm going to come back to this for you. So if I want to factor a polynomial, first of all I got to make sure it's in standard form, which this one is. And this is a trinomial. A trinomial generally factors into 2 binomials. So what I have to do is, to get this x squared, the first 2 in my FOIL, my first term, has to multiply together to get me x squared. The only way to get x squared is x times x. So then in your next term, these 2 terms have to multiply. So this one times this one has to multiply together and give me negative 5. And at the same time, I have to add these 2 terms together to give me a positive 4. So you've got to think of different combinations that if I multiply them together, I get negative 5, and at the same time, if I add them together, I get negative 4. So factoring can be quite the challenge if you get larger numbers, because the more possibilities you have, the harder the problem becomes. This can become very time consuming, and we'll talk about that later. So to get a negative 5 and a positive 4, I'm going to put in a plus 5 and a minus 1. Is 5 times negative 1 equal to negative 5? Yes, it is. And is 5 plus negative 1 positive 4? Yes, it is. So that should be the correct answer on that one. So basically this slide represents what I just told you. I had to multiply them together to get negative 5, and at the same time they had to add together to give me negative 4. And the only 2 numbers that work in that is a positive 5 and a negative 1. So all I did was insert that positive 5 and negative 1 into that. Okay? And now I'm going to show you the full method to make sure that works. If I multiply these two together, I'm going to get x squared. That's a minus 1x. That's a plus 5x. And that's a minus 5. If I combine those like terms, I've got x squared minus 1 and plus 5 is plus 4. And that should have been what I started with that original slide. Which there it is. So now I'm going to go back to the dividing once I've showed you the factoring. Like I said, the factoring can be a little challenging at times. And when we get to the other part about factoring, we're going to recommend that you not factor and not use completing a square. And we're going to jump straight to the quadratic formula for that. So now that I know how to factor, and if I did not know how to factor, I definitely couldn't have done these problems here. So this particular problem, 2x squared plus 4, the fraction bar divides the problem in the top and bottom, so you do top by itself, bottom by itself. I can factor a 2 out of both of these. If I take a 2 out of both of them, this is going to be the same thing as 2 times x plus 2. This has a 2 and this has a 2. Just like canceling fractions, I can divide both of them by 2, so the answer to that whole problem would have been x plus 2. In this particular problem, again, the fraction bar divides the problem in the top and the bottom. You do the top by itself, you do the bottom by itself. Can't do anything to the bottom. Both of the top ones have x plus 3 in it. If I take x plus 3 out of both of them, what am I left with? X minus 2. So now I got x plus 3 on the top, x minus 2 on the top. I got x plus 3 on the bottom. I can cancel out the whole x plus 3, so the answer to this entire problem will be x minus 2. The last one involves the factoring. That's why I went and took you to the factoring, because if you can't factor the top part, you won't get the correct answer. So on this top part by itself, fraction bar divides the problem in top and bottom. Top by itself, I got x squared minus 4x plus 3. For me to get the correct answer, I have to factor that trinomial into 2 binomial factors. The only way to get x squared is x times x. Again, these two terms have to multiply positive 3 and at the same time add up and give me negative 4. So I got to come up with two numbers that I multiply that gives me 3. And at the same time, they have to add together and give me negative 4. The only two numbers that will work in that particular situation is going to be minus 3 and minus 1. Negative 3 times negative 1 is positive 3, correct? And negative 3 plus negative 1 is negative 4, correct? So I'm going to substitute this in for this up here. So this is going to be x minus 3 times x minus 1. And if you'll notice, I can cancel these out. So the answer to that entire problem is going to be x minus 1. Again, if you don't know that, factoring, you won't be able to get the right answer to that problem. That's why I skipped to the factoring part first. Here we have two other examples. Again, the reason why we don't recommend that you do factoring unless you have to, if I can't factor that entire trinomial, I'm never going to get the right answer to this problem. The larger the number becomes in front of the x squared term, the more difficult the problem is going to be. You could spend countless minutes trying to figure out what combination of numbers that will factor to make that one work out. So if I can't factor these, chances are I'm not going to get the right answer. So I'm going to factor, first thing I see here, there's a 2, a 12, and a 14. So the first thing I know I can do there is I can take a 2 out of there. So I'm going to do 2. That's going to give me an x squared. That's it's going to give me a plus 6x. If I take 2 out, it's going to give me a minus 7. So on the top part only, if I take 2 out, I got x squared plus 6x minus 7. I got to try to figure out how to factor this trinomial into two binomials. And again, the only way to get x squared is x times x. I then have to multiply these two guys together and get a negative 7. And at the same time, they have to add up to a positive 6. The only two terms that will work for that would be a plus 7 and a minus 1. Let's see if that works. 7 times negative 1 is negative 7, correct? 7 plus negative 1 is 6, correct? So that's what that factors into. I'll bring my 2 down. So the entire top part now becomes 2 times x plus 7 times x minus 1. Now the bottom part by itself, they both have a 2 in them. If I factor 2 out of that, I'm going to have x minus 1 left. And if you'll notice, they both have, I can cancel out the 2's, top and bottom. I can cancel out the x minus 1's. It gives me a final answer of x plus 7. A lot of work for one problem, right? Factoring can be a time-consuming event. This one's going to be even harder, much more difficult, because I had a coefficient of 2 here. This one's got a coefficient of 3. The larger the number becomes, the more difficult it becomes to factor them out, and it can be quite time-consuming. That's why we're not going to recommend that you do it if you don't have to. I'm going to run this guy up top and give me some more room. I'm going to do 3x squared minus 23x plus 40. Again, I have a trinomial because it has 3 terms. I'm going to try to factor it into 2 binomial factors. Luckily for me, the only way to get 3x squared is 3x times x. Now for the fun part. These 2 numbers have to multiply together. This one is times, one of them is going to be times a 3, and one is going to be times a 1. So I can multiply one of them by 3, and the other one by 1. They have to equal 40, and at the same time, 3 times one of them and 1 times the other one has to add up to give me negative 23. So you can see how difficult that becomes. Now I've got to deal with not just a 1 and a 1, but I got to deal with a 3 and a 1. So which one goes where, and what combinations can I come up with? To get a 40, I'm thinking just off the top of my head, maybe 5 times 8. I could try that if I wanted to. There's other things I could consider. 4 times 10, 2 times 20. So as you can see, by the coefficient becoming 3, and the larger this number becomes, the problem becomes more complex, and you have difficulty trying to figure out what number goes where. So we're at the point to where we can figure out what 2 numbers go in here that I multiply one by 3, the other by 1, and then add them together and get negative 23. Are both of them positive, or are they both negative? Is one positive, one negative? You just basically trial and error, and like I said, you can sit there all day, basically not figure out how to factor some of them. I'm going to try 3 times negative 5, because that'll give me negative 15. And then negative 8 more should give me negative 23. So I'm going to try this to see if it works. Trial and error. If it don't work, I'm going to try something different. So I'm going to go with negative 5 times negative 8 is positive 40. Yes, it is. Let's see if this part works. 3 times negative 5 is negative 15. And negative 8 times x is negative 8. Is negative 15 and negative 8 negative 23? Yes, it is. So I think we have found our factor portion. And like I said, that can be very time consuming, very frustrating. Jamie gave you a website earlier. That also has factoring trinomials on it. You might want to give that a look. So now I'm going to replace finally, and Thanks for bearing with me. I'll replace all of that with 3x minus 8 times x minus 5. And I want to thank Jen for giving us such a difficult problem. We appreciate it. 3x minus 8 will cancel out to give you a final answer of x minus 5. Now we're going to jump to solving quadratic equations. There's 3 methods and 1 answer. Doesn't matter which way you do it. I just try to show you how difficult factoring could become sometimes. If you can't avoid it, you just got to do it. You got to do what you got to do. We don't recommend this. We don't really recommend committing the square because it can be another confusing step-by-step procedure that you have to memorize. We highly suggest that you use the formula, the quadratic formula, because it's always a formula, it's always available, and it's as easy as plugging in A, B, C. And at this time, I'm going to let Mr. Jamie Oates come back up and show you how to do the quadratic formula.
Charlie, now we're going to talk about the quadratic formula. It's a formula that you're going to see, as you see up here, on the task reference sheet. All right? And it looks crazy hard. But guess what? It's not. It's really not once you stop and you look and you dissect. Okay, this is our trinomial here. And as you see, we've got circles here. Okay, in these spaces, you heard Charlie say, this is as easy as ABC. Indeed it is. The number that's in front of this first variable, which in this case is 1, is going to stand, whatever number is here stands for A. Whatever number is in this coefficient place here, plus the sign, whether it's negative or positive, stands for B, and whatever plus the sign is in this last position is C. So as you can see on this one, A would be 1, or positive 1, B would be 3, and C would be negative 4. And from that point, we would just, in the infamous words of my good friend Charlie, plug and chug. So we're going to do an example here of that problem. Now we just listed that A was 1, B is 3, and C is negative 4. So I'm going to plug these into this formula. So as you can see, our formula, the top half of this is negative B plus or minus, okay, B squared minus 4AC within the radical sign, over top of the fraction 2A. Alright, so now I'm going to plug in my numbers in place of the variables. So B is going to be negative 3. I'm going to slide over here a little bit so we have some extra room. Negative 3 plus or minus. Go ahead and put this radical sign in there. B squared. So I'm going to put B squared, which is 3 squared, minus 4. And I'm going to put A and C in parentheses. A is 1 times C, which is negative 4. All that within that radical sign. Over top of all this mess, over top of 2 times A, which is 1. So now I just start looking at order of operations, more or less, from this point on. So I'm going to leave my negative 3 for right now. I'm going to leave the plus or minus. I'm going to pop my quadratic, or my radical sign back in. I got 3 squared. That's going to be 9. Okay? And then I'm going to have to multiply negative 4 times 1, which would be negative 4, multiplied by another negative 4. Those two negatives together come together to give me a positive. So I'm going to have 9 plus 16 within my radical sign, over top of 2 times 1, which would be 2. Okay, so now we'll slide up here to complete this problem. So now we've got negative 3 plus or minus 9 plus 16, and the radical sign is going to give me 25. All right, over 2. Square root of 25 is going to be plus or minus 5 over 2. So now I sort of do this. I do a two-part series here. I'm going to put this, because you've got 2 different answers you can have for x. Okay, because remember, we are trying to solve for x. All right, so my first part, I'm going to do negative 3, plus is on top, so I'm going to do plus 5 over 2. Negative 3 plus 5 gives me 2 over 2. 2 over 2 equals 1. So, for this problem, x would equal 1. Over here, I'm going to do negative 3 minus 5 over 2. Negative 3, taking away 5 more, gives me negative 8 over 2. And the answer to that will be negative 4. So x could be 1 or x could be negative 4. And it's as simple as that, ladies and gentlemen. That is solving a quadratic equation using the quadratic formula.